All right, so this problem is going to be about solving systems of substitution. So I'm literally going to do this as a lesson. The worksheet I created, that if you like it and want to use it, then basically you can head over to my webpage. In the upper right-hand corner, you should see at this point a card, and you click on that card really quick and open the link, and it will take you to the page where you can get this worksheet. Just scroll down through the page to find it, so you can have it. So if you want to follow along and print it off and do what I'm doing, you can. So anyway, let's get started. So we're going to talk about solving systems of substitution, and a couple of things we need to talk about here are basic principles. And one of the most basic principles we have here is this thing called the transitive property. And the transitive property states that if A equals B and B equals C, then two things must now be equal to each other, and it must be true. So the answer to that is, well, if A equals B and B equals C, I have B being equal to two separate things, so they themselves must be equal. So A must then equal C. That has to be true, okay? So that basic principle, called the transitive property of equality, now allows us to build this new, extremely important property called the substitution property. And the substitution property, all right, let's build on that down here below. So the way we build on that is this, okay? So substitution property building skills. So if A plus B equals C and B equals D, then blank equals blank must be true. So we're going to build back to this transitive property, okay, in which we had two variables, all right, interacting so that they were equal to something. In this case, the substitution property doesn't have one variable equal to two separate things, but it does have one variable equal to something. So that means that A plus B equals C. Well, what once was B can now be D. So therefore, I can rewrite this statement as A plus D equals C. So this must be true, okay, because B is the same as D. So we can add, okay, A or D or B, okay, to A and get the same number. So to show you this, right, so if I had numbers, so pretend for a second that I said 5, okay, plus 2 equals 7. And then off to the right, and this may be the part that doesn't make sense, that 2 equals 2. Does it really matter which 2 I use right here? And the answer to that is no. If I take this 2 and place it over there, I still get 7. Or if I take this 2 and place it over there, I still get 7. And that's kind of the idea that we're getting at here, that if B were 2, then D must be 2. So it doesn't matter which one I use. It's just a matter of they're both the same thing. All right, so that's the beginning of it. So one of the things you definitely want to have here is you don't necessarily need this piece in there, okay, but you definitely want to have the same number bit. All right, so we continue on. So given A plus 2B equals C and B equals D, then what must be true? So think about that for a second. All right, so here we go. Then the same thing occurs up here. What's important is you see this 2? It doesn't say that 2B equals D. It's just that the B equals D. So what we want to pay very close attention to is that you're not removing the 2 here, okay? So this is going to be A plus 2, and instead of 2 times B, I can now do 2 times D and still create this value of C. And this must be true again because of the same reason up here, okay? So if B is the same as D, all right, then it doesn't matter whether I multiply 2 by B or 2 by D and then add it to A, I'm still going to get C, all right? So down to number 3 here. All right, so number 3 says, given A plus B equals C and B equals D plus 1, then what must be true? And one of the things I want to point out to you here is that now this is a little bit different because I have B being equivalent to an algebraic quantity. So an algebraic quantity is the sum of a variable and a constant. And what you need to know is that this D plus 1, okay, must travel as a group. So when I take a look at this problem, all right, I'm saying that B can be rewritten as d plus 1. So in this problem, when I look at it, okay, instead of using b, I can replace it with, how do I get b? Well, I get b by taking d plus 1. So in this case, this one is going to be a plus. Now, here's the important part. Whenever you put a quantity in, a sum or a difference in, throw it in parentheses. So that b, okay, parentheses, and that becomes d plus 1 equals c. So when I read this, a plus the quantity of d plus 1 equals c. And the quantity of d plus 1 is b. So that's why I can replace it, all right? So the substitution property can be used to solve systems of equations. We use this method if and only if, okay, or if and when we have, all right? And the important thing here is, okay, we have a statement of equality, okay? You have to have a statement of equality, which means, okay, the rest of the sentence is basically just saying to you, you better have an equation that starts with x equals, y equals, or any other variable followed by an equal sign. So if you want to have a w equals, you want to have a z equals, you want to have an r equals, then we have a statement of equality. An example of a non-statement of equality, so this, okay, sorry, whoops, okay, something that is not a statement of equality, all right, not a, oops, sorry, I'm spelling that one wrong. Okay, so not a statement of equality that, okay, is substitution worthy. Okay, because if I write an equation, I have a statement of equality, but we need a substitution worthy one. So x plus y equaling 8 is not going to be a substitution worthy problem for us in solving systems of equations. Now, yes, I understand in higher order maths, x plus y will be, but for right now, for this method, what you really need to be focusing on is that you have one variable equal to something. Now, this one here is not worthy as it stands. I could make it worthy of that by rearranging it. But in this particular video, we're not going to worry about rearranging. This is just an introductory video to solving systems of substitution. All right? So, on to the next problem. So let's apply this. All right? So I have number 4. It says, given x plus y equals 12 and y equals 3x, calculate the solution of the system. So what we have here is, we need to be looking for our statement of equality. This first one here, x plus y equals 12, is not a statement of equality that allows me to directly substitute. All right? However, okay, when I go over here, this y equals 3x is. And the reason for it is because it says y is this. So y equals. I have a statement that one variable can be replaced with that quantity. So what we're going to do here is we're going to take this, okay, we're going to take this statement of equality and we're going to throw it into that problem. So basically what this means is anywhere a y is present, I can swap a 3x in its place. Okay, so let's do that. So I go to this problem. I'm going to write it out. X plus y equals 12. So I see a y right here. Okay, so here's a y. So what I'm going to do is I'm going to swap it out. So I'm going to remove that from the problem, and I'm going to put 3x in its place. So x, ooh, whoa, whoa. So x plus, parentheses, 3x equals 12. Now, why is this? What did this just magically do for me? This magically took something that had two variables, x and y, and put it into something that has one variable, okay? And it has x's. And now this is important because now I can do something called combine like terms. So I have x plus 3x, which makes a grand total of 4x's equals 12. And then from here, what I can do is I can solve this, right? This is solvable for a value before x and y equals 12. It's not solvable for a value using mathematical processes, but I now have that. So divide by 4, and you'll get x is now equivalent to 3. Now, Be very careful. Unless the question directly says, what is the x value? You have an issue if you stop here. You are in a system, and at the top of this page, this system is made up of an x, a y, and both equations are made up of both x's and y's. So it doesn't matter what you have, but if one of these equations has two different variables, you must find out the value of the other one. Now, the way you find out the value of the other one is that you take the current value that you have and you do what we just did before. Now, anywhere, okay, I go back into any one of these equations, and I'm going to go use this one. So now it's anywhere I see an x is present, I can swap it with the value of 3. So what I'm going to do is I'm going to go over here, and I'm going to do that. So I have this equation, y equals 3x. And by the way, it does not matter if I use x plus y equals 12 or y equals 3x. You need to use one of them. So pick one and just do this swapping. So anywhere I now see x, I can swap with a 3. So y equals 3 times 3. And 3 times 3 is a value I can calculate, and that value is 9. So I now have x equaling 3 and y equaling 9. Now, when you solve a system, you need to know that you are finding an intersection point. So a lot of times on multiple choice tests, it's not going to say x equals 3 and y equals 9, depending upon what your teacher has or whatever. But more commonly, what you'll see is the solution written as an ordered pair. And the reason we write it as an ordered pair is because a system is talking about where two lines intersect. This is the equation of a line. That is the equation of a line. I have two lines, and what I'm solving for is the point at which they intersect. So mathematically, I've determined that x is 3, y is 9. That right there is my point, okay, of intersection. All right, and that is the solution to my system. So let's do another one here. So moving on to another one. So number 5 here. Given the system x equals y plus 1 and x plus 2y equals 13, find the solution. So I am again looking for a statement of equality that is substitution worthy. X plus 2y is not substitutional worthy because it doesn't tell me that x is directly this or y is directly that. So this one above, all of a sudden, this one I'm highlighting in green here, that is my substitution worthy problem. And it states, wherever an x is present, I can swap it for the quantity of y plus 1. And notice that I put it in parentheses because the word quantity quantifies something and that groups it. So we move on. So here we go. I take that second equation and I go down to that second equation and I go, okay, I like to rewrite it again. If you don't want to, you don't have to. But x equals 2y, x plus 2y equals 13. And now I'm going to swap out an x and just simply replace it with that quantity. So wherever I see an x, so here's an x, I'm going to pluck it out of the problem, and I'm going to put in its place a y plus 1. So the quantity of y plus 1 plus 2y equals 13. And again, what did this magically do? It took something with an x and a y in it, and now I have a problem with just y's in it. So from here, I go ahead and simplify. So this group has a 1 in front, so I just have 1y and 1, 1. So 1, so this is important. So do distributive property here, right? So y plus 1 plus 2y equals 13. And I know it may seem silly that I just did the distributive property with 1, but if there were a 2 there, okay, that's important that we're not forgetting that I'm actually doing the distributive property to drop those parentheses. It's not like I get to magically drop those parentheses because they're there. I am distributing a 1. So that's an important piece, okay? So then we move on from here, and now I can do combined like terms, and I get 3y plus 1 equals 13. And now from here, I'm basically at the point where I can solve my two-step equation. The way you solve a two-step equation is you deal with subtractions and additions first, and you undo them. So I need to get rid of a positive 1. It needs to go bye-bye. So if I add 1, then I need to take 1 away. So I take 1 away, and I do that in the equation. I do it to both sides, take 1 away, and now I'm left with 3y equals 12. Last step, do some mental math. 3 times what is 12? And so y has to be 4. So now I have y. Notice the first time I did this, I solved for x first and then found y. So the order of which you solve things is not always going to be solving for x first or always solving for y first. You are going to solve for the problem based off of, you're going to solve for the variable based off of whatever your equivalency statements is. So now that I have y equals 4, what I can do is I can go back and pick an equation. Now, generally speaking, I will always plug my answer for substitution back into my equality statement. All right, because it's telling me how to find x directly. If I plug it into here, that means I got to do more work and solve another equation. It's not just like combine like terms and solve it or simplify. It's not just like a simple order of operations problem. So what I want to do is I usually like to take this and plug it into my equivalency statement for substitution worthiness. So x equals y plus 1. So now wherever I see a y in this equation, I can replace it with a 4. So x equals 4 plus 1, so x equals 5. And what I now have is my point. I write it as an ordered pair. Just because I found y first doesn't mean I write it first. I find the ordered pair in the order of which ordered pairs come. And all ordered pairs come x comma y. So I must write my solution as the x value I found first and then the y value second. All right? So this point, again, is my point of intersection. Moving forward. Determine the solution of the following systems of equations. So again, this is just a different looking format. So again, something that you may have here. You have y equals 2x plus 5, and you have y equals negative 3x plus 20. Oh my goodness, I have two equality statements. Which one do I use? And the answer is whichever one you want. You pick. You have to pick which one you want to use, but you only get to use one of them as an equality statement. The other one will become the place where I do the swapping. So I am going to pick, all right, the second one. I am going to say, all right, wherever a y is present, I can swap it for negative 3x plus 20. So I go to the second problem, I pluck that one out, and I go, okay, y equals 2x plus 5. And wherever I see a y, so here's a y, I'm going to swap it. I'm just going to switch, and I'm going to switch it for this quantity of negative 3x plus 20. So I go, and again, I'm going to use parentheses. So I go, and negative 3x inside parentheses plus 20 equals this 2x plus 5. And I know it seems arbitrary, but to do this, all right, but I'm going to. So now I had a 1y here, so I'm going to put a 1 there. Distribute your 1 through, and you should know multiplication by 1 gives you yourself. So I understand that, but I'm building a foundation that's important here, that I am using distributive property. I'm not just removing the whole thing that's with y. I'm just swapping out the y. Plus 20 now equals this 2x plus 5. So from here, I'm going to solve. So I have to use an order of operation because now I've got a variable on both sides. So what I need to do is I need to get variables together. So I need to combine my like terms. But when I combine my like terms, I need to remove one from one side. Well, how do I remove a negative 3x? Well, I add 3x. All right? So I add 3x. I add 3x. And what I'm left with is that 20 equals 5x plus 5. Now I need to isolate the x. So when I isolate the x, I need to get rid of that 5. So I have a positive 5, so I'm going to make it into negative 5. Negative 5. And now what I'm left with, okay, is that I have 15 equals 5x. And my last step now here to do is to divide by 5, and I will get x is equivalent to 3. Once I have my x value, what I now need to do is plug it back in. Now, the nice thing is you have two equivalency statements. Just pick one. So I'm going to pick the first one this time. Y equals 2x plus 5. So y equals, wherever I see an x, I can substitute a 3 in. So 2 times 3 plus 5. Y equals 6 plus 5. Y equals 11. My final answer, written as a coordinate pair, is going to be 3, 11. And then I'm done. All right, so on to the next problem here. What I'm going to do is, again, I'm going to look for my equivalency statement. And my equivalency statement here, okay, so the first equation says x plus y equals -8. But the problem is that is not a substitution worthy, because remember we're looking for that y equals x equals. So I go to the second equation and it says y equals. So that is the magic. That's what you're looking for, right? The y equals bit. So what that means is wherever I see a y, I can swap a quantity of -3x plus 4 in. So what you do is you go to the second equation and you write it down. The second equation is x plus y. In this case, it's the first row, but it's the other equation, equals -8. And wherever I see a y, I'm going to swap that y out for a -3x plus 4. So I get x plus, and in parentheses, -3x plus 4 equals -8. And yes, it's important. I want to point out to you that I do need to put the parentheses, and there's a plus, and I want you to understand something very important, that there was a 1y there, so there is a 1 in front of there. So that's 1y, right? So there's a 1 in front of there. So to drop those parentheses, I do actually use the distributive property. We just need to know, all right, that anything times 1 is just going to be itself. So to do this very quickly, 1 times anything is itself, so 1 times that group is itself. So anyway, distribute the 1, all right, you're going to get x minus 3x, because positive 1 times negative, and then 1 times 4 is positive 4 equals -8. So what I did there is going to be an important concept that I'm going to talk about later, and I'm going to come back and reference it, okay? So anyhow, from here, we just combine like terms. So I get -2x plus 4 equals -8. And then from here, it's about solving. So the opposite of adding 4 is subtracting 4. So that goes bye-bye, but it's equality, so do it to both sides. And you get -2x equals -12. And then from here, my last step is to undo multiplication. You do division. So divide by -2, divide by -2, and I will get that x is equivalent to 6. So now, once I have x is 6, all right, we want to find y. So to find y, I go to, and I plug that information into the equation that tells me how to find y. The one that tells you how to find y is your equivalency statement. It's the one that says y equals. So y can be found by doing -3 times x plus 4. So what's nice about that is that you literally just found out, okay, so -3 times x plus 4, you just found out that x was 6. So wherever I see an x, I now replace it with the number 6. So y equals -3 times 6 plus 4. And I get y equals -3 times 6 is -18 plus 4. So now be careful. A lot of people make the mistake when they do the mental math. -8 plus 4, they say -22. That is not the case. Okay, so -18 plus 4 is -14. So I have my x, I have my y. My last step is to put it in as a coordinate pair, which is 6, -14. So again, the answer I found is my point of intersection. So that's an important idea. Okay, all right, so on to the next one. Okay, so we have 2 more examples here. The 2 more examples we're going to go through here is going to be this x minus 4y minus 2, and we have this y equals 2x plus 22. So ironically, what I've got going on here is I've got an x equals, right? But I've also got a y equals. So notice I now have 2 equations that are both substitution worthy. So the question is which one do I use? And the answer to that is, it's your decision. You either want to use the x or you want to use the y. So what I'm going to do is, just because for the last couple ones I've used y's, I'm just going to use the x. So wherever I see x present, I can swap the quantity of -4y minus 2 in its place. Okay, so I write that second equation, and that second equation says y equals 2x plus 22. So what I'm now doing is I'm looking for the x. So here's my x. So there it is. And what I'm going to do is I'm now going to swap that x out, and in its place put that negative 4y minus 2. Now, what's extremely important here, okay? It is only this x that gets to get swapped out. You see this 2? The 2 does not get to go along with it. This is just an x. It is not 2x, so this 2 must stay put. So do not forget that the 2 doesn't go with it. A very common mistake is people just like to replace this whole expression here, but you can't get rid of this whole term. You leave the 2. It's just the x, all right? So what we'll get is y. Let me change that back. So y equals 2 times the group, the quantity, negative 4y minus 2 plus 22. So again, now this is important because that 2 out in front, so what I'm actually going to do, okay, to drop parentheses is distributive property. So what I need to do now here is distribute that 2. So distribute means to multiply. So 2 times negative 4 is going to be negative 8y. So y equals negative 8y. And then distribute the 2 to the negative 2. So 2 times negative 2 is negative 4. And I'm adding 22 to that. So from here, it's just about simplifying. So negative 4 and 22. So y equals negative 8y plus 18. The little thing I need to do here is I need to isolate the y. So I'm going to take this negative 8y, I'm just going to move it over here to this y. And by doing that, I do the inverse, so the opposite operation, which is instead of minus 8y, I put a positive 8y, and I'm left with 9y, oh, that's an awful 9, 9y equals 18. And the last step here to solve for y is to divide by 9, and I get y equals 2. Okay, so yet once again, just following along with the process. Once I have y, I take it up here and I go and I look for the equation that has the x equals, the way I find x. And the equation that tells me that is it says x equals, so x equals up here, I'm back up the original system, so x equals negative 4y minus 2. So what I'm going to do is I'm going to write this out. So I write it out again, so we get x equals negative 4y minus 2. And now the nice thing about me knowing that y is 2 is wherever I see a y, okay, I'm going to swap it out for a 2. So x equals negative 4 times 2 minus 2. So x equals negative 4 times 2 is negative 8. Negative 8 minus 2 is x equals negative 10. So what I've got is now negative 10 for x and 2 for y. So the coordinate pair is negative 10, 2. So again, the point that I just found is the point of intersection. Now, what I also want to point out to you is it does matter the way I write that coordinate pair in. Do not write it as 2, negative 10. If you write it as 2, negative 10, that is not in order. Remember, coordinate pairs come x comma y, not yx. So this is your y value, and that's your x. You got to put them in the parentheses the way they go. All right, on to the last problem here. So again, we're just following the process here, and we're looking for our equivalency, our substitution equivalency statement. So the first one here says 2x minus y equals 14. That does not have an x equals or a y equals. So we go to the second equation, and I'm hoping it says y equals or x equals, and lo and behold, it says y equals. So what this means again is that wherever I see a y present, I can swap the quantity of negative x plus 1 in. So we write that second equation. So again, we just go back. We write that second equation, which says 2x minus y equals 14. And from here, again, we're only swapping out the y. So here's a y. All right. I don't get to swap out this negative. That negative has to stay there. So it's extremely important. That negative must stay in the problem. I only get to swap the variable, nothing else, just the actual variable itself. So I go back and I write 2x minus, and now I get to swap the variable for this parenthesis, negative x plus 1, close those parentheses, put a 14. So now, important thing here. In front of the parentheses, notice there's a negative. Well, that means then, okay, that there's a 1 in front of it. So that's an important concept, okay? I talked about that before. If it's plus or minus in front of a parenthesis with nothing there, it's a 1. So now I need to distribute a negative 1, okay, a negative 1 in. So when I do that, I get 2x, all right, is the first thing, just drops down, has nothing to do with the distributive property, so negative 1 times a negative x is positive 1x. Negative 1 times positive 1 is negative 1 equals 14. So from here, I can combine my 2x and my 1x, which makes 3x. So I'm left with 3x minus 1 equals 14. Two-step equation left that I solve. So I have negative 1, put positive 1 below it. That makes 0. Positive 1 on the other side. I get 3x equals 15. Divide by 3 to break apart the multiplication. Divide by 3, and I get x is equivalent to 5. Once I have x is 5, again, I take that information. So I take this information, and I'll go back to the equation that tells me how to find y. And y is found by doing negative 1, okay, times x plus 1. So y equals, and I'm going to put the negative 1 there just so you see it. Negative 1 times 5 plus 1. So y equals negative 5 plus 1, because negative 1 times 5 is negative 5. So y equals negative 4. So from here, I get my final answer that it's 5 comma negative 4. Okay, so there you go. There you have it. We are now done. That was my last example, but just to again reiterate that this point that we just found is the point where the lines cross. So row 1 and row 2 in this equation, they're both lines. This is where they intersect. So just to point out to you, just to give you some things for you to have, if you like, is if you downloaded this work. There is some homework. Obviously, you're not in my class, so you don't have to do it, right? Unless you are in my class, then you have to do this. But there's some extra problems, and it's a hodgepodge of review. So the first page here will be, determining a point or graphing a line. So some good review problems here. Usually when you do substitution, you'll learn graphing prior to that. So here is some graphing. But then I will have 3 problems here for you to substitution. If you just want some extra practice, there you go, there you have it. Yeah, so if you download the worksheet, on that same page will be the answer key to these homework problems. So you can give that a look, all right? So I hope this helps. If you like it, you can give it a thumbs up. So good luck, and have a good day.